Hi all, welcome everyone to the second part video of the chapter electricity. In the previous video, we discussed it up to Ohm's law. If you haven't seen that, please watch that video before this one. In this part, we will be continuing our discussion from the topic combination of resistors. What is that? What are the methods in which you can connect the resistors? There will be two different methods. One is series combination, the other one is parallel combination. Let's see that series combination and parallel combination. Okay, I'm going to draw a circuit for series combination. What is this? This is the symbol for a resistor having a resistance value R1. Another resistor is connected after this having a resistance value R2. One more resistor is connected with it having a resistance value R3. I need a voltage. How to get a voltage? Connect a battery. What is a battery? Battery is a combination of cells, positive terminal, negative terminal. Battery is connected through a key to the circuit. Now, in the board you can see a combination of resistors in series. What is that? Resistors are connected one after the other. Okay. What are the properties of this series combination? Let's talk about that. What about current? Current always coming from higher potential to lower potential. Which is the higher potential here? Positive terminal is the higher potential. Negative terminal is the lower potential. So I'm going to mark the direction of current. Current is coming from positive terminal I to the negative terminal. So the same value of current is passing through R1. Okay, same value of current is passing through R1 and R2 and R3. Why? Because there is no branches. If there is no branch, current will not be splitting. The same value of current is passing through R1, R2 and R3. So you can say R1, R2, R3 are in series. Understood? Okay, I'm going to write that current is same. What about voltage? According to Ohm's law, voltage is the product of current and resistance. So what is the value of current and resistance here? The resistance is R1, current is I. So IR1 will be the voltage across this R1. I am calling that voltage as V1. Now, IR2 is another voltage. I am calling it V2. IR3 is another voltage. I am calling it V3. What is the meaning of that? Each resistors are having different value of voltage across them. So voltage is different. Voltage is different. Each resistor is having different voltages across it. Okay? Yeah. Now, this is applied voltage. So applied voltage will be the sum of these voltages. You can write V1 plus V2 plus V3. That will be the applied voltage. Okay. What is the resistance you can experience in this circuit? There is a name for that resistance. That is called effective resistance or equivalent resistance or resultant resistance. Okay. There is a derivation for that. I'm not giving you that derivation. I will just give you the equation. The equation for effective resistance in series will be Rs is equal to R1 plus R2 plus R3. That means you can just add the resistors. You will get the effective resistance. So this is the effective resistance in series. Okay. Now let's see parallel combination. There is one resistor here having resistance R1. Another resistor is connected parallel to it having a resistance value R2. One more resistor having R3 resistance is connected parallel to it. I am going to connect a battery to it. How to do that? This is the battery connected to this combination through a key. Positive terminal, negative terminal. I am going to mark the direction of current. Then you will understand why this is parallel. Okay. The current is coming from positive terminal. Okay, what happens to the current at this junction? At this junction, the current will be splitting because you can see the branches there. So the current will be splitting, and an amount of current I1, I am calling it I1 because the current that is passing through R1, I am calling it I1. An amount of current is passing through R1. Another part of current I2 is passing through R2. One part of current I3 is passing through R3. There will be different currents. Okay, and what happens to the current at this junction? They will be combining to form I again. They will be combining to form I again. What is that? The value of current that is coming out of positive terminal is I. The value of current that is coming to the negative terminal is I. What can you understand from that? What is the current coming out of the positive terminal will exactly be equal to the current coming to the negative terminal. Did you understand that? That is very important. Keep that in mind. Okay, now what about the current? What about the current? Current in each resistor is different. Current in each resistor is different. I am writing it. Current in each resistor is different. Okay, what about voltage? Let's see the voltage across R1. If you want to find the voltage across R1, you can measure the voltage across this point and this point. But R2 is connected to the exact same points there. R3 is also connected to that points. If you are measuring the voltage, you will be getting the same voltage. Same voltage across R1, R2 and R3. That will be the applied voltage V. Okay, that will be the applied voltage. Okay, now you can say the voltage is same. Now you can say the voltage is same. Okay, who is splitting here? Current is splitting. Current I is splitting. I can be written as I1 plus I2 plus I3. This is the total current. Okay, yeah. Then what is the effective resistance here? The resistance you can experience. We have an equation for that. I am not giving you the derivation. 1 by Rp can be written as 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation to find the effective resistance in parallel. Okay, now I am going to give you some special equations. What is that? Some special equations. What is the first one? If you have n number of resistors and you are connecting them in series, let's see that. Let's see that n number of identical resistors in series. What is identical resistors? Each resistor is having the same value. Okay, what is that? First resistor, second resistor, third resistor, fourth resistor, etc. up to n number of them. Each of them are having the same value of resistance R. How to find the effective resistance in series? R1 plus R2 plus R3, right? So R plus R plus R plus up to n. That means n times R. What is that? N times R. So this is a very simple equation to find the effective resistance in series if you have n identical resistors in series. Right? Okay. Now the second special equation, if you have a n number of identical resistors and you are connecting them in parallel, what will be the effective resistance? Let's see. N number of identical resistors in parallel. What will be the effective resistance? Let's see. First resistor connected parallel to the second resistor, that is connected parallel to the third resistor, etc. Each of them are having the same value of resistance R. They are connected in parallel. Okay. How to find it? How to find the effective resistance? There is a simple equation to find effective resistance in parallel if the value of resistors are identical. That is very simple. It will be R by N. What is this N? N will be the number of resistors in parallel. Okay? It's a very simple equation, right? Yeah, see that? A very simple equation. Okay. Now, this is about a combination of resistors. Let's see the first question. Let's see the first question. What is that? Calculate the effective resistance between A and B in the circuit given below. Yeah, you can see 2 points there. There is a point A, B. Okay. You can see a combination of resistors there. 4 ohm, 6 ohm, 15 ohm, 3 ohm, 3 ohm. Some of them are in series, some of them are in parallel. What is the effective resistance? The resistance you can experience here. How to find that? How to understand if a resistance, two resistors are in series or parallel? Let's look at the current. If the current is splitting, they will be in parallel. If the current is not splitting, if the value of current through the resistors are the same, they will be in series. Let's see that. Let's see that. Okay, so current is coming like this. Current is coming like this. Then what happens to the current at this junction? The current will be splitting through these branches like this. Okay, that makes this and this branch, also this branch in parallel. The branches will be in parallel. Now the same value of current that is passing through 4 ohm is also passing through this 6 ohm. That makes this 4 ohm and 6 ohm resistors in series. Okay, now the same value of current is also passing through 3 ohm and this 3 ohm. That makes this one and this 3 ohm in series. Understood? Okay, let's use that idea to find the effective resistance. I'm going to find that. What is this? I'm going to take this branch first, that is 4 ohm and 6 ohm. 4 ohm and 6 ohm are in series. 4 ohm and 6 ohm are in series. How to find the effective resistance in series? RS. RS has this equation, R1 plus R2. Yeah? Yes. Okay, so what is R1? 4 plus R2 is 6. 4 plus 6, 10 ohm. Now, RS is 10 ohm. That means I have a resistance of 10 ohm here. Okay, that is the effective resistance of this branch. That 10 ohm is parallel to this 15 ohm. Yeah. Now, this 3 ohm is in series because the current is not splitting. Yeah. Then I am going to write that. What is that? 3 ohm and 3 ohm are in series. They are in series. How to find the effective resistance in series? RS is equal to R1 plus R2. But they are identical resistors. So I can use the other equation. What is that other equation? N times R. What is N? Number of resistors in series. Number of identical resistors in series. So that will be 2. 2 into the value of resistance. That is 3. 2 into 3, 6 ohm. Effective resistance is 6 ohm in this branch. Yeah. Okay, now I am going to redraw the figure. There is a 10 ohm here, a 15 ohm, then another 6 ohm resistor here. How to redraw is? How to redraw this? Let's see. This is a 10 ohm resistor in parallel with the 15 ohm resistor. That is in parallel with the 6 ohm resistor. Okay. What is this combination? A parallel combination. How to find the effective resistance in parallel combination? We have the equation 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the equation for effective resistance in parallel. Let's substitute the values. 1 by 10 plus 1 by R2, that will be 15, plus 1 by R3, 1 by 6 is equal to 10, 15, 6. You can use the LCM method. What is the LCM? 30 will be the LCM. So 30. How to get 30 from 10? How to get 30 from 10? Into 3. So 1 into 3 plus how to get 30 from 15 into 2. That means 1 into 2 plus how to get 30 from 6 into 5. So 1 into 5. Okay. So 1 by RP can be written as 3 plus 2 plus 5 divided by 30. 5 plus 3, 8 plus 2, 10. 10 by 30. But that is not effective resistance. That is not effective resistance. What is that? That is only 1 by RP. 1 by RP is 10 by 30. How to get RP? Take the reciprocal. RP is equal to 30 by 10. What is that? 3 ohm. So what is the effective resistance between A and B? That will be 3 ohm. Okay, that was the first question. Let's see the next one. Let's see the next one. For the circuit shown in this diagram, there is a 7 ohm, 5 ohm, 10 ohm in parallel. That combination is in series with this 7 ohm. Okay, calculate the resultant resistance. What is the resultant resistance? See, this 5 ohm and 10 ohm are in parallel. How to understand that? If a current is coming here, it will be splitting here. Okay, so I am going to find the effective resistance of that parallel combination first. 5 ohm and 10 ohm are in parallel. Okay, how to find the parallel resistance? 1 by RP can be written as 1 by R1 plus 1 by R2. What is it? That will be 1 by 5 plus 1 by 10. Take the LCM. 10 is the LCM. Okay. So 1 into 2 plus 1 into 1. What is it? That will be 2 plus 1 divided by 10. You can write 3 by 10. That is not the effective resistance. That is only 1 by RP. If you want to find RP, RP will be 10 divided by 3. What is that? That will be 3.33 ohm. I am just taking it as 3.3 ohm. So I have the effective resistance of that combination. I am going to write 3.3 ohm here. Now I may need to redraw the diagram because this 7 ohm and a 3.3 ohm are in series now. Okay, so I am going to draw that a 7 ohm, and another 3.3 ohm resistor is connected across a battery of 6 volt, positive, negative. This is my circuit actually is. Okay, 7 ohm, 3.3 ohm in series. How to find the effective resistance right now? How to find effective resistance? Now 7 ohm and 3.3 is in series. So effective resistance can be found by effective resistance. What is the equation for that? It's in series. So effective resistance in series R1 plus R2. What is R1? That will be 7. 7 plus 3.3. You will get 10.3 ohm. Effective resistance is 10.3 ohm. Okay. Now I have the answer to the first question. What is the second one? What is the total current? That is the second one. Let's find the total current. Total current. Second sub question. How to get the total current? You can use Ohm's law. According to Ohm's law, voltage is equal to current into resistance. Yeah, what is the current? Positive terminal, negative terminal. Current will be coming out of positive terminal and it is going to the negative terminal. The same value of current is passing through 7 ohm and 3.3 ohm. That is the current through the effective resistance of 10.3 ohm will be this I. How to find this current I? I is equal to voltage divided by resistance. What is the value of voltage? 6 The value of voltage is 6 divided by effective resistance. That will be 10.3. I can write it 10.3. What is the value of current? 6 by 10.3. When you do this, you will get a value 0.58 ampere. That is the value of current through this circuit. What is that? 0.58 ampere. Yeah. So we have the second answer. Now look at the third one. What is the third one? Third one is the voltage across 7 ohm resistor. Okay, let's see that. Voltage across 7 ohm resistor. What is the equation for voltage? That is current into resistance. What is the current flowing through the 7 ohm? That will be 0.58 ampere. The total current, right? Okay, so I am going to write the equation for voltage across 7. Voltage across 7 ohm will be current into resistance of that part. What is the resistance? That will be 7 ohm. Then what is this? Current is 0.58 into, what is the resistance value? Resistance value is 7. That will be 58 into 7. You will get 406. 406. Take 2 places. Then it will be 4.06. 4.06. So what is the voltage across 7 ohm? That will be 4.06 volt. Okay. Total voltage is 6 volt. A 4.06 volt is appearing across this 7 ohm. Where is the rest of the voltage? Rest of the voltage can be seen here. Okay. Yes. That means we have answered 3 sub-questions. Let's see the next question. What is that? Third one. Yeah, it's an interesting question. Look at that. Which 2 resistors are connected in series? You can see a circuit there. There is R1, R2, R3, R4, R5. Different resistors are connected in different way. The question is, which 2 resistors are connected in series? How to understand if 2 resistors are connected in series or parallel? We have to look at current. If the current is splitting, they will be in parallel. If the current is the same through the resistors, they will be in series. Let's see that. What is it? Okay, this is positive terminal, negative terminal. So the value of current is coming here. I am calling it I. I is passing through R4. Okay, when I is reaching this junction, what happens to I? I will be splitting. If current sees a junction, it will be splitting. A value of current is passing through R3. I am calling it I3. Another value of current is through R2. I am calling it I2. Okay. Now, when this I2 and I3 is reaching this point, what happens? You have to understand something. Current will always choose the easiest path. Current will always choose the easiest path. At this point, current will look at the circuit. Then think, there is a path here and here. Which path will be chosen by the current? Now, this path has a resistance R1. But this path is just a wire connection. There is no resistance. That means current will choose that path. Current will not be flowing through this R1. R1 is gone from the circuit. R1 is no longer in the circuit. Current will be combining here. I2 and I3 will be combining here. Then it becomes I again. And that I will be flowing through this connection. And the current I will be going through R5 also. Did you understand this? What is that? Current will choose the easiest path. Which is the easiest path? Which path has the least resistance? Look at this. This path does not have any resistor connected to it. So that will be the easiest path. The whole current will be choosing that path. There is no current through R1. So R1 is out of the circuit. Did you understand this? Now let's answer the first question. Which two resistors are connected in series? Which two resistors are having the same value of current? What are they? R5 and R4 are having the same value of current. So they are in series. Understood? They are in series. That is your first answer. What is the first answer? R4 and R5 are in series. R4 and R5 are in series. Okay. Now look at the second question. What is that? Which two resistors are connected in parallel? Where the current splits, they will be in parallel. Where the current splits, see I3, I2 through R3 and R2. That means R3 and R2 will be parallel. That is my second answer. R2 and R3 are in parallel. Okay. Now look at the third question. What is that? If every resistor of the circuit is 2 ohm, what current will flow in the circuit? Okay. Every resistors are having the value 2 ohm. Let's see. R2 and R3 are in parallel. Yeah. R2 and R3 parallel. If you have two resistors, two identical resistors in parallel, what is the effective resistance of this combination? You have that equation, effective resistance in parallel. If the resistors are identical, there is a similar equation, R by N. What is the R? R is given as 2 ohm. Okay, so 2 by N, number of resistors, that will be 2. So 2 by 2, what is that? 1 ohm. 1 ohm is the resistance of this combination. Okay, I am going to redraw the figure. It's like this. It's like this. A 5-volt battery is connected to R4. Okay, here you have R5. Now R1 is not in the picture. It is out of the circuit. There is no current through that. That means you don't have to draw the R1. The connection is like this. Now I have an effective resistance here, that is just 1 ohm. RP, 1 ohm. Now what is the effective resistance? What is the effective resistance? If you need current, you have to find effective resistance. Effective resistance. Look at that. They are in series. So what is RS? RS can be written as R5 plus R4 plus, what is this? This is RP. Effective resistance of this combination. So what is R5? 2 ohm plus 2 ohm plus 1 ohm. What is that? What is that? That will be 5 ohm. Now I have the effective resistance. Effective resistance is 5 ohm. Effective resistance of this circuit is 5 ohm. According to Ohm's law, what is the current coming out of this positive terminal? I. That is current. What is the equation for current? What is the equation for current? Current is I equal to voltage divided by effective resistance. What is the voltage? Voltage is 5 divided by effective resistance is 5 also. So 5 by 5, that will be 1 ampere. 1 ampere is the amount of current in the circuit. How is this question? It's a very good question. Now let's see the next one. What is it? Heating effect of electric current. Okay. I'm going to draw a circuit here. The resistor is shown. The value of resistance is R. Now this resistance is connected to a battery, positive, negative, through a key. Okay. If the key is switched on for a long time, then the current will be flowing through this resistor. Okay. Yeah. Then the resistor will be heating up. That means a heat is produced in it. This is heating effect of electric current. Huh? You can understand that with Joule's law. Joule's law is H is equal to I square RT. This equation is Joule's law. How to understand this? How to state this? Look at that. The heat produced in a resistor is directly proportional to square of the current for a given resistance and directly proportional to resistance of the conductor for a given current and the time for which the current is passing through the conductor, passing through the circuit. Understand? That is Joule's law. What is that? Joule's law. Okay. So if the current changes, if the resistance value changes, current will be changing. So that's why there is some conditions in the Joule's law. That is Joule's law. Another equation is there for heat. I am going to give you that equation. We will discuss how you are getting that equation a little bit later. So H can also be written as V square T by R. This is also an equation for heat produced in the resistor or conductor. Okay. Now let's see the next question. What is that? Fourth one, two identical resistors of resistance R are connected in series with a battery of potential difference V for time T. Okay. The resistors are then connected in parallel with the same battery for the same time T. Okay. So that means there are two different connections. Compare the heat produced in the two cases. Okay. I am going to take the first case. What is the first case? Two identical resistors having resistance value are connected in series with a battery having voltage V. Okay. So it will be producing a heat. How to find that heat? I'll be using this equation V square T by R. Why is that? Because I have a voltage and resistance here. What is the effective resistance here? This is series combination. So effective resistance in series can be written as R1 plus R2. Both of them are having the same value. Identical resistors has this effective resistance NR, that will be 2 times R. Effective resistance is 2R. What is the equation for heat produced? That is V square T by R, effective resistance. Okay. So H can be written as V square T by 2R. I am calling this H1 because that is the first case. Yeah. Now the second case. Read the second case. The resistors are then connected in parallel with the same battery, and the resistors are connected in parallel. First resistor is connected to the second resistor, which is in parallel. Okay, connected to the same battery. So voltage will be V. Yeah, voltage and resistor is given, resistance is given. So I will be using this equation. How to find the effective resistance in parallel? If you have identical resistors in parallel, we have a simpler equation. What is that? That will be R by N. What is this? This is R by 2. That will be effective resistance in parallel. What is the equation for heat? This is the second case. So I am taking it as H2. H2 will be V square T by Rp, effective resistance in parallel. What is that? This will be V square T divided by Rp is R by 2. So what happens to these two? 2 will be coming to the top. Then I have H2. What is H2? H2 can be written as 2 into V square T by R. Okay. That means I have H1 and H2. What is the question? Compare the heat produced in the two cases. How to compare them? Just divide them. You will get the comparison. I am going to divide H2 divided by H1. H2 by H1. So 2 V square T by R divided by H1. What is H1? H1 is V square T divided by 2R. What happens to this V square T by R? It will be gone from this equation. V square T by R is gone. That means you will get H2 by H1 as 2 divided by 1 by 2. 2 divided by 1 by 2. What is that? The 2 will be coming to the top. So H2 by H1 is 2 into 2. Yeah? 2 into 2. Okay. So H2 by H1 can be written as 4. What is H2? H2 will be, bring this H1 to the other side. It will be 4H1. What is H2? H2 is the heat produced in the second case, that is in parallel case. H1 is the heat produced in series. So heat produced in parallel is 4 times. Heat produced in series will be 4 times lesser than the heat produced in parallel. Okay, or the opposite. Heat produced in parallel. Heat produced in parallel combination is 4 times greater than heat produced in series. Heat produced in series. Okay. So that's our answer. We just compared the heat produced in 2 cases. Okay, that's our 4th question. Let's see the next one. What is it? Electric power. What is that? Power. What is it? Rate of electrical energy dissipated or consumed in an electric circuit. Let's see that. Let's understand that. There is a resistor having resistance R connected to a battery. The same circuit we have been using for long. The voltage is V, positive terminal, negative terminal. If the switch is on, a value of current will be passing through that. Okay. Now we just saw that a heat is produced here. Heat is a form of energy. That means an energy is consumed at this resistor. Okay. So the rate of energy consumed is called power. What is that? The energy consumed per unit time, that is power. Is that okay? This is the first equation of power. That means there will be different equations for power. What is the general equation for power? Power can be written as work divided by time. That is power. General equation for power. We have the equation for voltage. Voltage is equal to work divided by charge. We have seen this in previous video. Voltage is equal to work divided by charge. So work can be written as voltage into charge. Yeah. Okay. So P can also be written as voltage into charge divided by time. What is this charge divided by time? Charge divided by time is actually current. Rate of flow of charge is current. That means you can write this equation as voltage into current. What is this? What is this? This is the electrical power. What is that? Electrical power. So I have the first equation, the second equation. According to Ohm's law, what is voltage? Voltage is current into resistance. If I give the value of voltage here, I will be getting P is equal to voltage is current into resistance. IR into I. I am going to write it. IR into I. What will be that? Power is equal to I into I squared R. See that? Power is equal to I square R. Third equation. Okay. Now, according to Ohm's law, I can write another equation for current. What is that? Voltage is equal to current into resistance. Then current is equal to voltage divided by resistance. Give that equation here. P is equal to voltage into current. Current is now V by R. So power can also be written as V into V, V square divided by R. What is that? That will be the fourth equation for power. See that? Power is powerful. Huh? What are the equations? Power can also be written as energy divided by time and voltage into current. It is also I square R, square of the current into resistance. Power also is V square divided by R. Okay? Yes. What is the unit of power? Unit of power is watt. Capital W is the symbol. Okay? Yeah. If you have power, I am going to write some equations for heat also. Heat is a form of energy. What is the energy equation from this? Energy equation E is power into time. From this equation, you will get power into time. That is energy. Heat is a form of energy. So you can write H is equal to power into time. How many equations does this power have? That many equations will be for heat also. What is the first equation? You can write the first equation, H is equal to power into time. Power into time. V-I-T. 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 First equation. Okay. Second one. Second equation of power. What is that? That is I square R. So multiply with T. I square RT. Second equation. Are you familiar with this equation? Yes, H is equal to I square RT is Joule's law. That is Joule's law. H is equal to I square RT, that is Joule's law. Right? Okay. Now the third equation. I square R. So H is equal to I square R. We already have that equation. Now V square by R. V square by R. Then H can be written as V square by R into T. We have seen this equation also. V square T by R. That is the third equation for heat. Okay? Yes. So this is about electric power and some equations of heat. Let's see the next question. What is the next one? Read it. State which has a higher resistance, a 50 watt lamp or a 25 watt bulb. I am going to write a 50 watt lamp, a 50 watt lamp and a 25 watt bulb. Which has higher resistance? That is the question. And how many times? How many times? Let's see that. What is the equation connecting power and resistance? That will be V square divided by R. The equation connecting power and resistance, if the voltage is same, assume voltage is same, then the equation is V square divided by R. The relation can be written as P inversely proportional to R. Okay? Inversely proportional to R. That means if power is high, resistance will be low. Understand? If power is high, resistance will be low. Yeah. Then which will be having the higher resistance? Which has the lower power? Which has the lower power? 25 watt bulb has the lower power, that will be having higher resistance. That is my first answer. 25 watt bulb has higher resistance. Higher resistance. Okay. How many times? How to find that? What is the equation for resistance? Equation for resistance will be V square divided by P. Equation for resistance will be V square divided by P. Okay. So equation for resistance of 50 watt lamp will be V square divided by 50. 50 is the power. Now resistance of 25 watt bulb will be V square divided by 25. Okay? Yes. Now compare these equations. Compare these equations. How to compare them? How to compare them? We know how to compare them. Just divide them. R50 divided by R25. is equal to V square divided by 50, V square divided by 50 by, then V square divided by 25, V square divided by 25, the V square is gone. 25 will be coming to the top. Then I can write R50 divided by R25 is equal to 25 divided by 50. That will be 1 by 2. Okay, so I am bringing R25 to the other side. R25 is equal to 2 to the other side. Then 2 times R50. Look at that. Resistance of 25 watt bulb will be 2 times larger than the resistance of 50 watt bulb. Okay, that will be your answer. That will be your answer. Clear? We can move to the next question. Yes. Okay. Yeah. We are going to see electrical energy and cost. Okay. The electricity board will be billing us at the end of each month. What are they billing us for? Are they billing us for the current we are using or the voltage we are getting? No. They are billing us for the energy we are using. If there is a bulb here, a tube light, an AC, every electrical equipment will be using an amount of energy. They are billing us for the energy we are consuming. Okay, that will be a huge value of energy. The usual unit or SI unit of energy is joule. If we are stating that in joule, it will be a huge value. So we need a commercial unit for electrical energy, that is kilowatt hour. That is kilowatt hour. Commercial unit of electrical energy is kilowatt hour. How to convert kilowatt hour into joule? Let's see that 1 kilowatt hour is 1 into kilo is 10 raised to 3 watt into hour. Hour into second. Convert hour into second. How to do that? 3600 second is 1 hour. This is what? This can be written as 36 into 10 raised to 3 plus 2 10 raised to 5 watt second. What is this watt second? We have the equation for power. Power is work divided by time. So work can be written as power into time. What is the unit for work? We have the unit for work as joule. Joule is equivalent to, what is the unit of power? That will be watt. Unit of time, second. So watt second is joule. I can write this as joule, but in standard form it will be 3.6 into 10 raised to 5, no, 10 raised to 6 joule. Okay, that will be 1 kilowatt hour. Clear? Okay. Now you can see the next question. This kilowatt hour can also be called a unit. 1 unit. Okay. Yes. Our sixth question. In a household, 5 tube lights of 40 watt each are used for 5 hours and an electric press of 500 watt for 4 hours every day. Calculate the total energy consumed by the tube lights and press in month of June. Okay. What is the cost of the energy for June at the rate of ₹3 per unit? Let's see that. In the household, there is 5 tube lights. I am going to write that. 5 tube lights of 40 watt used for 5 hours daily. Okay. Then there is an electric press. Only one electric press. What is the power? Power of that electric press is 500 watt. It is working for 4 hours daily. Okay. I need to find what is the energy consumed per day. How to do that? How to do that? Energy consumed by, let's find the energy consumed by these 5 tube lights. Energy consumed by 5 tube lights per day. What is the equation for energy? power into time. Okay, but there are 5 tube lights, so 5 into power into time. That means 5 into, what is the power? Power is 40. 40 into time. Time is 5 hour. I am doing this in hour. So 4 into 5, 20, 200. 5 into 200. That will be 1000 watt hour. I didn't convert that. So 1000 watt hour. Now I am going to find the energy consumed by one electric presser. There is one electric presser. So one electric presser per day. In one day, what is the energy consumed? There is only one electric presser. So you can find that by P into T. What is the power? Power is 500 watt into time. What is time? It is working for 4 hours daily. 500 into 4. That will be 22 zeros. What is that? 2000 watt hour. Okay. Now you have the energy used by 5 tube lights in one day, energy used by electric presser in one day. Find the total energy consumed in one day. That is the next one. Energy consumed in one day. Energy consumed in one day. What is the energy consumed in one day? Just add them. What is that? 1000 plus 2000. You will get 3000. So 3000 watt hour is the energy used in one day. Convert that into kilowatt hour. How to convert watt into kilowatt? Watt into kilowatt, you just have to multiply with 10 raised to minus 3. So this will be 3000 into 10 raised to minus 3. You can write kilowatt hour. Okay, then it will become 3 kilowatt hour. This is the energy consumed in one day. Then what will be the energy consumed in the month of June? June has 30 days. I'm going to find that. What is that? Energy consumed in the month of June. In the month of June. June has 30 days. So what is the total energy consumed in 1 month? In 1 day, that is 3. So 3 into 30. That will be 90 kilowatt hour. 90 kilowatt hour or 90 unit. Okay, 90 unit. What is the cost per unit? Cost per unit. Per unit, they are going to bill us for 3 rupees. 3 rupees for 1 unit. Then what will be the total cost? Total cost. For 1 unit, 3 rupees. That means for 90 unit, 90 into 3 rupees. Very simple, right? So 90 into 3 rupees. What is that? That will be 270 rupees. So the bill for these electrical equipments for month of June will be 270 rupees. How is this question? A very simple question, right? Once you understand that, that's a very simple question. Let's see an MCQ. What is it? What is the maximum resistance which can be made using 5 resistors each of 1 by 5 ohm? That means you have a resistor having the value 1 by 5 ohm. Such type of 5 resistors you have. What is the maximum resistance you can get from this? If you connect them in series, you will get the maximum resistance. If you connect them in parallel, you will be getting the least resistance. Is that clear? Okay. So you have to connect them in series. You have to connect them in series. 1, 2, 3, 4, 5. Everything is connected in series. What is the value of one resistor? The resistance value is 1 by 5 ohm. What is effective resistance in series? we have a very simple equation. What is that? N times the value of resistance. That will be 5 into 1 by 5. See, 1 ohm. That will be 1 ohm. So effective resistance, that will be 1 ohm. That 1 ohm will be the maximum value of resistance you can make from this 1 by 5 ohm. Okay, you have 5 such resistors. Yes. So what is the value? What is the correct option? The correct option will be D, 1 ohm. Yes. Now, let's see the next one. In a resistive circuit, if the current is increased to 2 times, the percentage change in the amount of heat dissipated in the circuit would be. For that, we need to find the heat first. What is the value for heat? H is equal to I square RT. This is the equation. Because they are talking about the current. That's why I am taking this equation. H is equal to I square RT. Now, according to the question, they are saying the current has changed. So I am giving that value I dash. Current has doubled or 2 times. So the new current is 2 times the old current. Then the heat has changed, H dash. H dash will be 2I the whole square RT. What is that? 2 square is 4, 4I square RT. That is H dash. What is I square RT? I square RT is H. So you can write H dash is equal to 4 times H. H dash has become 4 times. So is the answer 400%? No. Read the question carefully. The percentage change in the amount of heat. You need to find the percentage change in the heat. So what is change in heat? Change in heat. Change in heat will be H dash minus H. H dash is the larger value. So H dash minus H will be the change in heat. That is 4H minus H. 3H. So 3H is the change in heat. Convert that into percentage. What is that? That will be 300%. Okay. I'm going to give you an equation to find this. Maybe you will be studying this equation in higher classes, or yeah, you can just study this one here itself. What is that? The equation is for percentage change in any quantity. Percentage change in any quantity will be change in quantity. This is an equation. Change in quantity divided by original quantity into 100. So according to this equation, what is change in quantity? Change in heat. Change in heat here is 4H or H dash. I will start with that. H dash minus H divided by original quantity. Original quantity is original H, old H, into 100. What is H dash? H dash is 4H minus H divided by H into 100. What is that? 4H minus H, 3H divided by H into 100. H is gone. H is gone. So 3 into 100. What is that? 300%. So what is our value? Our value is 300%. Did you understand that? What is the equation for percentage change? This is the equation for percentage change. Change in quantity divided by original quantity into 100. Okay. Now, the next one. An electric kettle consumes 1 kilowatt of electric power when operated at 220 volt. Let's write the power. What is the power of the electric kettle? 1 kilowatt. I am converting that into watt. I am not doing the calculation in kilo. So 1 into 10 raised to 3 watt. What will be that? 1000 watt. That's the power. Okay. When operated at 220 volt, so the voltage is given. What is the voltage? Voltage is 220 volt. Okay. A fuse wire of dash rating must be used for it. What is the rating of a fuse wire? rating of a fuse wire is given in ampere. Rating of a fuse wire is given in ampere. What is the meaning of that? If this is a fuse, its rating will be given in an ampere amount, in a current value like this, 6 ampere. What is the meaning of that? What is the meaning of that? If a current if the current more than this 6 ampere is coming through this fuse, it will be melting. Understood? It will be melting if a current value more than 6 ampere is coming through this fuse. Otherwise, it will hold that current. That's the meaning of that. So, rating of a fuse will be given in ampere. That means you need to find the current here if you want the rating of the fuse. What is the current? Power is equal to voltage into current. Then current is equal to power divided by voltage. Right? Okay, what is power? Power is 1000 watt divided by voltage is 220 volt. Cut the 0, 100 divided by 22. You will get 4.5. Okay, so the current used by this kettle is 4.5 ampere. If you are using a fuse that will be rated below this value, what happens? It will melt right away. So you cannot use a rating of fuse below this value. You just have to use a rating. You just have to use a fuse just above this value. Just above this value. That means you may have to use 5 ampere fuse. 5 ampere fuse. You may have to use a 5 ampere fuse, then it will hold that. When a current of 4.5 ampere is drawn from the mains, the fuse will hold it. When a larger current more than 5 ampere comes, it will be melting. Is that okay? Okay, let's see the next one. Yeah, this is our last question. Assertion, reason type of question. Read the assertion. Tungsten metal is used for making filaments of incandescent lamp. What is an incandescent lamp? Incandescent lamp is looking like this. It is filament lamp. What is the filament made of? Filament will be made of tungsten metal. Okay, so assertion is true. Yeah, assertion is true. Okay. Now look at the reason. What is reason? The melting point of tungsten is very low. Is the melting point of tungsten is very low? No. What are the properties of tungsten metal? Tungsten is having very high melting point. Very high melting point. Okay. What is the working of an incandescent bulb? An amount of current will be passing through this filament. Filament has very high resistivity. So, it will be producing heat. It will become red hot. It will become white hot. When it produces a large amount of heat, it will become white hot. Then it will glow. It will produce light. That's how it is producing light. That means it will be having very high value of melting point. It will not melt that easily. So, look at the reason. Reason is wrong. Reason is wrong. Did you understand this? Okay. So, assertion is true. Reason is false. That's the end of our discussion for this chapter. We have completed the chapter electricity. We have done some numerical questions, some MCQs, some assertion reason questions. Everything is done. Now, we will be meeting with another chapter. Until then, bye. See you. And best wishes for the exams also. Yes.